Hi guys, this is Carl again. This is week 3, problem number 8. We'll go ahead and dive right into it. One measure of the difficulty of the golf course is its length. The longer, the more difficult. Kind of professional golf courses, run several thousand, maybe 7,000 yards. So what we have here is a survey, or summary of a survey rather, of 45 golf courses, specifically the length, how many yards. And our histogram is right over here. Remember previously, from what we learned, that right here, this output, this is multi or unimodal. You can tell this is unimodal, one peak, uni. It's a key word, just in case when you're looking at it. Because remember, it's one mode, one most frequently appearing variable, or length rather, in the survey of these golf courses. And over here is our summary statistics. We know mean means average, standard deviation, minimum, median, max. Quartiles we haven't really gotten into much up to this point, or at least not to a great detail. In terms of quartiles, remember quarters. What's a quarter? 25%, 25 cents, quarter of a dollar. In this way, it kind of shows you the values. So if you break down these 45 golf courses into quarters in terms of their length, the hierarchy of it all, and by the first, or now you notice how it's flipped. So as you get higher in the number, you're getting higher in your quarters, meaning the lengthier the golf course. As you can tell, so the bottom 25% of the 45 golf courses, it's up to 5,572 yards. That is the max point of the top of the bottom quartile, rather. So, and you can tell as you get 3/4 in, you're getting 6,100 yards. So you're getting longer. So the kind of the up to 75, between the 50 and the 75th percentile, I guess, is kind of the best way to point about this. Kind of like test scores or SAT scores. Your score will put you in a certain bracket compared to all the other scorers, either state or national, in this regard. Same way here. So up to the 50 to 75th quarter, the max point is 6,100 yards. So we'll go ahead and get started in terms of our questions. What is the range of these data? So when we talk about the range, we want to know, okay, so how much distance is there between the longest golf course and the shortest? And so that's easy. Arithmetic solution to it is our min versus our max, or minus our max rather. Max minus our min, I'm sorry. So in this case, we're going to take our maximum, which is 66.51, and minus our minimum, 51.33. So that's going to get us 1,518 yards. So what that means, in synthesizing this a little bit, is that there is 1,500 yards, roughly 1,500 yards, separating the longest and the shortest golf course. That means that the 45 golf courses are within 1,500 yards of each other in terms of the lengths. Which, in terms of a survey, that's pretty good, considering golf courses aren't really abundant around in a particular state. So our next question, between what lengths do the central 50% of these courses lie? Remember, we were talking about this earlier in terms of quarters, between the upper and the lower quarters in this case. So by quarter 1 and quarter 3, remember quarter 3 is that 70 between 50 and 75th percentile. That's the third quarter, remember? So between 1 and 3 is that 50%, that central 50%. So it kind of gives you a good sense of where that will be. Now, what is the central 50% of these courses? It's exactly that. Remember, it's quarters. 50% is 2 quarters. So just to give you a sense on that, so that you'll find them between the upper and the lower quartiles. The next question is, what summary statistics would you use to describe these data? Kind of a key and most frequently used summary statistics rather, in these kinds of work is your mean and your standard deviation. You want to synthesize how long, in terms of yards, are the courses that we're talking about. And so if the average is 50 or 5,400, as we see here, the mean, and the standard deviation is 397, that means that we've got some pretty good variation in terms of yards, kind of applying real world to this, that means that some courses might have longer holes, where it's, in terms of golf lingo, par fives as opposed to par threes. So it gives you a good sense. And remember, there's the central limit theorem, how all of your sample data, or 99% of it rather, is going to fall within 3 standard deviations of the mean. So what does that mean? That means that if you took this standard deviation multiplied by 3, we'll just go ahead and type it in just for effect. So 397.69 times 3. So any point is going to fall, any point, when I say any point in this case, I mean any golf course length. 5,000 yards, 6,000 yards, any golf course length is going to fall between, at the very maximum, this mean, 5,400, plus this. Any course. That's the rule. That's the rule of thumb that we're talking about here. So, let's go ahead and try it out. That means let's test this out. 6651, is that going to get us where we need to go? The 54, 58, 78 plus this value. Does that does that get us where we need to be? Yes. So what that tells us is that it just gives us a good sense of the spread, of what kind of spread are we talking about, which is what we're looking at when you're talking about describing the data. What's the spread of the data? The mean and the standard deviation give you the best sense and the scope of how varying this data can be, how varying the golf course lengths could be. If it's a smaller standard deviation, what does that mean? In kind of thinking about this problem from a real world perspective, is that there's not as many long holes. There's not as many, the lengths, if the lengths are so skewed towards the mode, right, and thinking of it in this way, if they're so skewed towards, say, 6,000, that would mean that this average would have to be 6,000. But if all were skewed towards the mean, that means that really there's not a lot of variation. A lot of golf courses keep their lengths within 5,500, 5,600. So with this tells you that there is a pretty defined spread of golf courses. And so next question, kind of relative to our homework, we'll write a brief description rather, of these data: shape, center, spread. So when you want to talk about that, in this case, this is a symmetrical unimodal. Remember, we answered it earlier, just kind of getting ahead of ourselves, but it's also symmetrical in that there's a distribution on each side, and it is a clean line chart. And the center of the data is blank yards, and the distribution has a spread of blank yards. So remember, to solve this one, it's our mean and standard deviation. Why is that? Because it's symmetrical and it's unimodal. So that, because of those two factors, that allows us to use the mean and standard deviation. So the center of the data is 5,458. That's our center in this case. Now, the distribution has a spread. Now remember, the spread is 397 yards. So the spread is the standard deviation, and the center is our mean, 5,458 yards. So that's generally what you could do. You could also say that technically the spread of the data is 3 standard deviations to the left or to the right. But in this case, we're kind of just simplifying to an effect of 397 yards. So with that, just let us know if you have any questions about this along the way. But thanks so much. Bye-bye.